Those massive caterpillar bulldozers pushing just literal mountains of earth, you kind of have to wonder, right? How does a beast like this even come to be? Well, inside one massive factory, thousands of precision parts, giant robotics, and highly skilled engineers all come together to build one of the absolute toughest machines on Earth. It is a total marvel of advanced manufacturing, and today we're going to break down exactly how they do it.
To really appreciate this, we first kind of need to wrap our heads around the sheer scale we're dealing with here. We are talking about a machine that weighs over 70 tons. To put that into perspective, that's roughly the weight of an entire herd of elephants. It packs over 800 horsepower and treats mountains of dirt like they're just sand. It's built for mines, massive construction sites, just the harshest environments out there. Building something this massive and this durable, yeah, it's no small task.
Okay, let's dive right into this. Here is the factory roadmap we're going to follow. 1. Forging the giant frame. 2. Power and hydraulic muscle. 3. Tracks and massive blade. 4. Smart tech and yellow paint. And finally, 5. Extreme performance testing.
All right, step 1, forging the giant frame, taking it from raw steel to skeleton.
Here on the factory floor, the transformation kicks off, and the contrast here is just wild. On one hand, you've got these multi-ton steel plates that literally require powerful cranes just to move them an inch. But then, laser-guided machines slice through that same massive steel with delicate, millimeter precision. It's not just brute force, you know. Every single component is meticulously measured before it's even allowed to move down the line.
Once those pieces are cut, the skeleton really starts taking shape. Heavy-duty robotic welders swoop in to join these thick steel sections together. We're talking thousands of robotic welds creating this indestructible frame, and they definitely don't leave anything to chance. Advanced sensors inspect every single weld to ensure maximum strength because, well, this frame is going to face decades of brutal punishment out in quarries and infrastructure projects.
Moving on to step 2, power and hydraulic muscle. Basically, the beating heart of the machine.
Now, a heavy steel skeleton is cool, but it isn't much use on its own. So massive overhead cranes carefully lower a heavy-duty diesel engine right into the frame. Once that's seated, workers jump in to meticulously connect a vital network of systems. We're talking cooling systems, intricate hydraulic lines, fuel systems, electronic controls, and a massive heavy-duty transmission. Every single connection gets rigorously tested before the machine moves forward.
While that diesel engine brings the power, it's the hydraulics that give the bulldozer its superpowers. Giant pumps, huge cylinders, and thick hoses are installed to grant the machine immense hydraulic muscle. This is exactly what lets the blade lift and push thousands of pounds with pinpoint accuracy. And because of the crazy high pressure involved here, every single hydraulic circuit is strictly pressure tested before this phase is considered a wrap. All right, step 3, tracks and massive blade. Time to gain some traction.
So how does a 70-ton behemoth navigate soft mud without just sinking? Well, bulldozers don't do wheels. They ride on heavy steel tracks, and these are assembled link by link. Workers install large rollers, idlers, and drive sprockets to complete it. This heavy steel undercarriage is absolutely critical. It distributes that enormous 70-ton weight across the ground, which gives the machine its incredible traction in the absolute worst environments.
Next up is the part everybody instantly recognizes, that massive front blade. You might think, oh, just slap a giant piece of steel on the front, but actually it requires special lifting equipment to position it with millimeter accuracy. Engineers then connect powerful hydraulic cylinders and carefully align every single component. That exact alignment, it's totally crucial for smooth, responsive operation when this thing is under a heavy load.
Phase 4, Smart Tech and Yellow Paint. Let's look at the finishing touches.
Now it's time for that iconic signature look. The machine rolls into a giant paint facility where automated sprayers first apply a heavy-duty, corrosion-resistant primer. Then comes that world-famous caterpillar yellow finish. But they don't just leave it to air dry. The whole machine goes into these giant curing ovens to harden the paint. It's an intensive process, but it guarantees long-lasting durability against rain, mud, and corrosive mine environments. Next, they drop in the operator cab. And honestly, stepping inside is like entering a high-tech command center. It is loaded with features to protect and assist the driver. You've got crystal-clear digital displays, highly precise joystick controls, and a fully air-conditioned cabin, which is a lifesaver in extreme heat. Throw in safety cameras giving a full 360-degree view and advanced monitoring systems, keeping track of the machine's health. Yeah, this is definitely not your grandfather's tractor. I think this brilliantly illustrates the whole duality of modern heavy machinery. On one side of the ledger, you have just incredible brute strength, a massive diesel engine, heavy steel tracks, and powerful hydraulics capable of pushing literal mountains. But right there on the exact same machine, you have smart technology, digital displays, safety cameras, and complex electronic controls. It really is this perfect marriage of raw physical power and a sophisticated electronic brain.
Finally, step 5. Extreme performance testing, the ultimate trial.
Before leaving the factory, the machine faces the ultimate test. And this isn't just a quick visual once-over. Engineers fire the engine up to an absolute roar, pushing hydraulic pressures to their limits. They slam the steering and brakes, aggressively articulate the blade, and run deep computer diagnostics to hunt for even a single digital glitch or microscopic fluid leak. Only the machines that survive this brutal gauntlet get to leave the factory floor. So we started with flat plates of raw steel, and we ended up with a 70-ton technological marvel. The next time you see a giant Caterpillar bulldozer shaping a road, clearing land, or working deep in a mine, what are you going to see? Will you just see raw steel and brute force? Or will you see the thousands of precision parts, the giant robotics, the advanced computers, and the skilled engineering that brought it to life? It really gives you a whole new appreciation for the hidden complexity behind the world's toughest machines. Thanks for joining me on this explainer, and keep your eyes open for the engineering marvels all around.